All right, thank you for coming. Let's get some notes down here. So on 60 in the book, when you did these problems, you may not have even realized that what you were doing was an indirect proof or proof by contradiction, but that's what we do. So if we want to find out if these work or don't work, we have to assume something. So I'm going to assume that these three sides make a right triangle. So I'm going to assume that they are. If I assume that they are, then that means that 5 squared plus 14 squared is equal to 20 squared. So when I do my math of my 5 squared plus my 14 squared, 5 squared plus 14 squared, that is equal to 221, and then 20 squared is 400. Well, that is not true, and that contradicts what's supposed to be true from the Pythagorean theorem. And so I say, therefore, the opposite, this is not a right triangle. Indirect proofs are normally pretty short. So let's do a similar thing here. This was another one of the problems here. And so we are going to assume the three angles form a triangle. And if that's true, then 59 plus 63 plus 57 is equal to 180. So I do my addition there. I get 179 is equal to 180. Well, that's not true. So therefore, this is not a triangle. That's it. That's all you have to do. Assume one thing, go until it contradicts something else, and then move on from there. Let's make sure on number 12 you did get it correct. In order to be congruent, we need to be similar and equal. So similar means equal angles and equal ratios. And equal means 1:1 ratios. So in order for things to be congruent, we need to be similar as well as equal, so same shape and same size. So similar would be any of the methods that you know, and then we would also need to show a 1:1 ratio. All right, we have two other ones to look at. Let's go ahead and look at 15, our class notes for a parabola. With a parabola, you can plug in a bunch of points, or you can really figure out where the roots are and then go from there. So the roots we mean by the x-intercepts. And if you want to know where it's crossing the x-axis, that means we want to know where y is equal to 0. So we're going to factor to solve. And zero product property says that this is equal to 0 or this is equal to 0. If this is, we get 4, 0. If this is, we get negative 2, 0. So we're going to go ahead and graph our points. And once I have that, my vertex is going to be exactly in the middle, because this is symmetrical. So this is my line x equals 1. So my vertex has a 1 as the x coordinate, and then we're trying to figure out the y. And we have a beautiful little equation there, so we plug in our x into this little guy up here, and we get negative 9 as our y value. So we're right down here. This then lets us know what other points to plug in, so I need to figure out what's happening right over here, so I'm going to plug in 0. When I plug in 0 for x, I get negative 8 for y. And when I plug in negative 1 for x, I get negative 5. So this is our gorgeous little curve of a parabola that we've got. So, big key thing, figure out what the roots are by plugging in 0 for y. Figure out the middle for our vertex, and then plug in some additional points on the other side. All right, last one for right now, class notes. We're simplifying with square roots. So if I want to use quadratic formula, I do need to set it equal to our happy little 0, and then we use our quadratic formula. So we have positive 10, because negative b plus 1 minus the square root of b squared minus 4ac all over 2a. So we get 100 minus 88 is 12. We simplify the square root, which is root 4 and root 3. Now, 6 and 2 are also factors, but neither one is a perfect square. The perfect squares the 4, so that is the one that's going to be helpful. So the square root of 4 is really 2, the square root of 3 is the square root of 3. And then this needs to be distributive to both. So one way to write that is 10 fourths plus or minus 2 root 3 over 4, which this reduces to 5 halves, and this reduces to 1 half. And a simpler way of writing that, since they have a common denominator, is this. But the key thing is you can't just get rid of those, and you certainly can't do that because that's under the square root and that's not. So it's got to go into all 3.